We take considerable pleasure in dedicating this picture to that vast multitude of America's automotive technicians like you fellows in this audience. Through their combined skill and know-how, they are responsible for keeping more than 51 million vehicles rolling on our nation's highways. Yes, a salute to those mighty men of wrenches and micrometers. And a salute to those early pioneers who had so little with which to work. This 1804 model Victoria pulled the world's first trailer. It carries a boiler, and it was really hot stuff in those days. Here is the engine, the engineer, and the fireman. These early automobiles are now classified as antiques and are found only in museums. Since the beginning of the industry, Thompson Products has contributed greatly to the advancement of the American motor vehicle. And these millions of vehicles are likewise doing their share in supplying the wants of many millions of Americans who live in communities not served by the railroads. Their manufacture, maintenance, and everyday needs provide employment for more than 9 million persons as they move over our streets and highways at the rate of more than 500 billions of miles each year. Nearly 200,000 gasoline stations are required to provide food for hungry engines. From Detroit and vicinity to every city and hamlet in the nation, new vehicles are speeded over the highways to more than 44,000 car dealers. Likewise, highway bus transportation blankets the entire country, serving cities and small towns alike. Yes, even the railroads have gone automotive. Mighty diesel engines now pull our long freight, power our high-speed passenger trains as they race from terminal to terminal. Even the lowly switch engine has taken on a new look. Believe it or not, here comes one down the road. Keep your eye on this unit, and you'll see a very versatile piece of equipment. It is centered over the track, and the flanged wheels are lowered to the rails. The rubber-tired wheels are now raised from the ground, and you see a real, honest-to-goodness switch engine. As it couples to this pull car, note that the weight of the car is placed upon the trackmobile. This pulls into the rail over traction as its four-cylinder truck engine provides tremendous torque. Ordinarily, this switching operation would be accomplished by a steam or diesel switcher costing many more thousands of dollars, to say nothing of the greatly increased costs of maintenance. In this particular operation, a switch engine consigned to the rails would have to backtrack over several miles of railroad to get to a new spur for further switching movement. But our trackmobile, which is installed in other parts of the yard and other switching assignments, barely moves to the nearest highway crossing. The rubber-tired wheels are now lowered to the pavement, and the unit is raised from the rails. It now becomes a highway vehicle, ready to roll down the road. And there he goes, to another part of the yard for a new switching operation. The airlines of America have freed the traveler from the earth. Their routes in the skies trace a 400,000-mile network that has shrunk the world to a neighborhood. In a single generation, they have grown to a giant of the air age and of transportation, mighty in times of peace and in times of war. We salute the scheduled airlines of America and the great industries that gave them wing and motor. We at Thompson are proud of the part we have played in the conquest of the skies. We likewise are justly proud of our engineering and manufacturing ability in the development and making of the vital parts of the turbojet engines that power our jet fighters and bombers. This is really hot stuff, and the terrific thrust developed by these mighty power plants gives them the power to race through the ether with almost unbelievable speed. Getting back to Earth, let us look on the inside of one of our automotive power plants. Here we see the pistons doing their job of changing reciprocating motion into rotating power. Properly metered fuel and air is drawn into the cylinder, compressed, fired, and exhausted into the atmosphere. In modern engines, air-fuel ratios must be carefully analyzed, and air cleaners and oil filters must be cleaned at regular intervals. When these factors are neglected, rapid cylinder wear is the result. Here are shown the effects caused by badly worn cylinders. Ring gap movement is exorbitant, which causes excess ring groove wear, as well as shortening the natural life of the engine. Note the ring gap as it opens and closes at the top of the stroke. This is a good example of badly worn cylinders. Note the ridges at the top of the bores. Failure to remove these ridges when new piston rings are installed will end in disaster. Many times the rings are blamed for failure, but in reality the mechanic is at fault. As you will see, failure to remove the ridge will allow the sharp edge of the new ring to strike the rounded part of the ridge, thereby causing extreme pressures on the ring lands, which in turn causes irreparable damage to the piston. We wish to keep you reminded that the modern automotive power plant is an instrument of precision. All of these component parts must work in perfect harmony in order to produce satisfaction for the owner. For instance, worn cam lobes make proper valve timing a difficult job. They should be regenerated. The worn cam lobes are being reground to their original contour for better valve operation. This is a badly worn lobe, and approximately 10,000ths of the metal will be removed to bring it to its correct shape. The master cam controls the shaping of the proper contour of the lobe. This operation is very important in high-speed, high-powered engines. This lobe is now finished with its proper contour and ramp angle, as good as new and ready to give the valve its correct lift. In addition, be sure to check valve lifters for wear. Always check valve spring pressures. They should be as near alike as possible. Check valve guides for wear. If worn beyond 50% of normal clearance, discard them and replace with new ones. With all of the valve train components carefully inspected, reconditioned, or replaced, we face the ever-present hazard of gas leakage through the valve port. A minute leak immediately develops a torch-like reaction which causes the valve to first become red and finally come to a white heat. This condition is often caused by uneven tightness of cylinder head bolts, poorly ground seats, improper timing, or lack of tappet clearance. At these extreme temperatures of 1400 and 1600 degrees, even the best of valve and hard-facing materials will meet destruction. Another type of failure, more expensive than burning, is the broken valve. Here in animation are shown the conditions which bring about metal fatigue, which finally results in a broken valve. The contributing causes are engine overspeeding, excessive tappet clearance, worn valve guides, worn tappets and rocker arms, weak valve springs, and warped decks caused by scaled water jackets, or poor practice in the tightening of the cylinder head bolts. Thompson produces valves for all makes of internal combustion engines, large ones for stationary or industrial type engines, midgets for our numerous labor-saving single-cylinder putt-putts, also some with special retainers for unusual applications. Finally, the standard type used in the millions of passenger cars and trucks. Valves are designed for each individual make of vehicle. Steels are of the best known for heat and corrosion resistance, and hard facing is applied where required. Hard-facing materials are applied to the entire seating area to provide hardness to resist pounding and abrasion and resistance against burning. It is plainly visible on this cutaway sample. Where the best-known valve steels and hard facings do not properly serve an engine, a hollow stem design with sodium added as a cooling agent must be used. At left is a light truck design, a heavier duty design at right. Actually, all automotive designs are taken from a background of experience in aircraft. Here is a cutaway aircraft design currently used with unquestionable dependability in both military and commercial air transport service. Since sodium cooling is so commonly used, an explanation of this cooling principle will be given. Here is a conventional hollow head valve partially filled with metallic sodium. Sodium has the characteristic of becoming a liquid of the consistency of milk at 200 degrees. Likewise, with the sodium in liquid form at valve operating temperature, we will let Pee-wee demonstrate. It is as simple as putting out a fire. By this process, heat from the head is transferred to the valve stem and finally to the valve guide, where it is dissipated through the cooling system. Uh-oh, looks like Pee-wee's in trouble. Another innovation which Thompson has added to the automotive industry is valve rotation. This mechanism is known as the roto-cap. It is used as original equipment on many makes of engines. It is a simple mechanical device which replaces the conventional spring cap. When pressure is applied during the opening cycle of the valve, the rotating motion takes place. Let's look inside and see how it works. By this action, the valve is caused to rotate approximately 6 degrees with each opening and closing of the valve. Note how the upper washer, which is called a Belleville washer, flexes with each cycle of motion. By design, the pressure required to flex this washer is balanced against the valve spring load. Notice how the flexing washer forces the balls down the incline, compressing the small springs. As the balls roll downhill, a rotating motion takes place. Small springs return the balls, and it is ready for a new cycle. These actions make it possible to extend valve life from 2 to 5 times. Some reasons for this life extension will be illustrated. The lifting action of the tappets and rockers, combined with the spring load, normally cause a slight cocking of the valve in the guide. It is shown here in exaggerated form. With rotation, the carbon which normally forms on the valve stem is constantly wiped off. Without rotation, there is the constant problem of deposits forming on the valve face. If they are allowed to accumulate, a thick layer will form on the seat, which is often uneven in density. Actually, deposits can lift the valve from its seat, causing leaks and eventual burning. With valve rotation, there is a light wiping action taking place between the valve and its seat. This wiping action is gentle in nature, but will constantly remove the deposits, keeping a metal-to-metal contact between the surfaces, which provides better heat conductivity, a cooler valve, and extended life. Yes, valve rotation is sweeping the industry. Born in the Thompson laboratories in 1938, available for production in 1945, it has had steady growth in both original equipment and service. Thus, Thompson Engineering has accomplished another achievement for the betterment of the automotive industry. Knowing the importance of valve rotation, the Ethel Corporation, in cooperation with Thompson Products, has launched a program to aid the farmer in securing better valve service in his tractor. This brochure will be sent to some 17,500 tractor dealers throughout the United States. And this pamphlet describes in detail the 3 types of valve rotation: the free valve, the vibration type, and the positive roto-cap. Only Thompson manufactures all 3, of which the roto-cap is the most popular for both original equipment and service. Also cooperating in this program is the National Retail Farm Equipment Association and their 17,500 dealers throughout the nation. They are pledged to aid the farmer in securing better service from his tractors. Thompson Products is cooperating with the Ethel Corporation and the Association with this type of advertising in popular farm journals. The Ethel Corporation is carrying on another advertising program. In it, they call the farmer's attention to the importance of valve rotation in their farm equipment. This benefits the dealer as well as the independent repairman. The valve seat is another important part of the valve train. Here are some suggested procedures for their installation and care. Accuracy in positioning the pilot is of prime importance if the seat grinder is to do its job with precision. Likewise, the stone should be carefully dressed for the proper angle. Be sure to follow manufacturer's specifications as to proper width of seat. When installing valve seat inserts, be sure to check the guide for accuracy. Worn guides throw the pilot out of alignment and contribute to early valve failure. The insert recessing tool must be carefully placed into position for this all-important operation. The cavity will then be bored to a perfect 90-degree angle to the valve guide. Be doubly sure that the cutter is really sharp. If not, a rough cavity will be the result, as is seen in this close-up. Driving seat inserts into a rough cavity is bad practice. It is one of the principal causes of valve seat insert failures, as they soon work loose in their recesses under operating temperatures. One of the common hazards experienced in driving inserts to place will be illustrated. The seat insert is normally some 3 to 4 thousandths of an inch larger than the cavity. Likewise, when it is tapped into position with the common hammer, it is only natural for some shearing action to take place. This removal of material tends to reduce the press fit. Also, the fine chips prevent the seat from resting in the cavity with complete metal-to-metal contact. Lack of contact reduces the heat conductivity. Both lack of interference fit and lack of contact are detrimental to good valve seat life. A preferred method of installing the seat insert is to first reduce the diameter by freezing. Dry ice or a common freezing unit will do it. With reduced diameter, there will be no shear. Likewise, as the temperature rises, the seat will be in position with proper fit and complete metal-to-metal contact is assured. Leaving the valve train, we come to pistons, another important part of the internal combustion engine. Since pistons are the connecting link between combustion and crankshaft rotation, they are exposed to the combustion flame on top, which again brings about the problems of heat, expansion control, and lubrication. Here are three common piston designs: the U-slot aluminum design, the plain cast iron tin plated, and the commonly used T-slot aluminum alloy type. Here is Thompson's new heavy-duty design with a steel belt in the upper skirt. A heavy rib extending in the direction of the pin bosses. These combined make one of the finest pistons known today. To illustrate how it operates, it is shown exaggerated in animation. A continuous steel belt is cast in the piston skirt. This belt is graphite coated, so there is no adhesion between the steel and aluminum. Likewise, as the temperature is increased, the aluminum, in expanding, will follow the contour of the band, greatly reducing the diametrical expansion. A rib of metal in the head section serves two purposes, by providing brute strength and a path for heat flow to the skirt area, where it is finally dissipated to the water jacket. The rib, positioned in line with the pin bosses, directs expansion in line with the bosses. Belted pistons are finished in an oval shape by cam grinding. Extra clearance is allowed at the pin bosses and a quiet running fit is assured on the thrust faces. As the engine comes to a normal running temperature, this controlled expansion carries the pin bosses out in the cam clearance area, but maintains normal running clearance at the thrust faces, thus eliminating all tendencies to score. A companion to all pistons is the piston ring. Thompson again has the exclusive ULEX design with characteristics destined for heavy-duty service. Here, in a special plastic holder, is shown a ULEX in round form, and left the same in oval form. This illustrates complete conformability. For comparison purposes, look at the conventional oil ring. Note the size and number of oil drain slots and the nature of its rigid structure. Now, compare it to the ULEX design. The open area, which is oil flow area, is many times greater than the conventional cast iron type. Now, a view of the conventional expander oil ring. Note that it is a used ring. The contact points show signs of wear, which means they are points of high pressure. This can be more clearly shown on a pressure distribution chart. Again, the high pressure points are clearly visible. High pressure points are common to both types of conventional iron rings, plain or expander type. Turning to the ULEX pressure distribution chart, the flexibility and unusual conformability features are again pronounced. Since the ring has the ends butted and it is made of numerous spring-like segments, the pressure is equal throughout its circumference. The oil handling ability of the two types of rings should also be compared. Note the clogged condition of the oil drain slots. No oil can pass through these. With the UFlex, it is true that there is some accumulation of carbon. But the flexing action prevents deposits from adhering, and they remain as an oil passage. The oil pattern found on a cylinder surface is a measure of the piston ring's ability to conform to the cylinder, as well as a measure of its restriction to free oil passage. During periods of high engine output, certain cylinder distortions are present. They are caused by both heat and operating strains. Conventional rings fail to make complete contact under these conditions, leaving large areas of heavy oil film. These contribute to high oil consumption. With the UFlex ring, the pattern is entirely different. The ring being composed of numerous flexible segments, slight cylinder distortions present no problem. Complete contact is always maintained, leaving a uniform, metered quantity of oil on the cylinder wall. The numerous drainage slots are also a factor in maintaining equal distribution of oil. Ring flutter is the most frequent cause of ring breakage. Flutter is occasioned by small humps or irregularities on the cylinder wall. For emphasis, it is shown in exaggerated form. Irregularities become a fulcrum point for bending with the conventional iron ring. Minute bending, taking place twice with each engine revolution, sets up a high-frequency vibration, the common cause for ring breakage. The UFlex, with its flexibility, again has no problem with irregularities. The minute bending action is taken in stride. Actually, the flexing is an aid to the UFlex because it prevents carbon particles from adhering to the ring. Likewise, the UFlex has some unique characteristics not apparent from its outer appearance. Now, let's consider piston ring weight. The ring itself changes direction twice for each engine revolution. Likewise, the amount of mass that must stop and start twice is important. By actual weight, the conventional ring is 3½ times the weight of a UFlex. It is no wonder that original equipment manufacturers use it. Another important feature to consider is the break-in qualities. The normal cast iron ring has rather sharp edges, intentionally designed to give quick seating, but they rapidly wear away, decreasing the unit pressure. With the UFlex design, the area in contact with the cylinder wall gives a high unit pressure, and it remains almost constant throughout the life of the ring, a feature desired for good ring performance. Precision parts will not function in dirty engines, hence a thorough cleansing of all components is compulsory. This is the latest in modern cleaning equipment. Two 5-horsepower electric motors drive 2 marine propellers which provide a 185-mile tornado of solution movement which removes grease, sludge, and carbon from water jackets, cylinder heads, and oil leads. Thermostatic controls automatically maintain a constant temperature of 195 degrees. The basket of engine blocks and other parts has been in the tank for a period of 9 minutes. Note the remarkable cleanliness of these engine parts. So clean you could eat your lunch on them. The approximate cleaning cost is about 8 cents per engine. It is extremely important that clogged water passages be free from scale, such as shown here. Under this condition, heat from valves and guides cannot escape. Thoroughly cleaned water jackets promote better engine efficiency. Owner and repairman alike should insist on an exacting cleansing job on all parts before starting precision operations and final assembly. In order to assure the piston and rings a good bearing surface, cylinders should be rebored with extreme care. Your Thompson jobber is equipped to do this expert operation, as well as many other machine shop services. For a partner in precision and in work-carrying capacity, there is nothing more reliable than our CL77 bearing. We call it the ugly duckling, but it was not made for beauty. It is made with a steel outer shell of sufficient gauge to maintain support of the compound layers of bearing metal. The first layer of bearing metal is a copper-lead alloy, alloyed to give maximum load-carrying ability. Next, a thin layer of pure nickel, which acts as a screen to prevent the bearing metals from migrating. The fourth layer is an overplate of an alloy composed of both tin and lead. This combination provides a Babbitt-like surface, which is the best wearing surface that is known today. It serves equally well on both conventional and hardened shafts. Actually, operators have found this ugly duckling a faithful servant. Here are displayed a pair of bearings with 234,000 miles of service written on their surfaces. Only 1/2,000th of metal has worn away. Actually, from all appearances, they are ready for reinstallation. Likewise, all the claims of load-carrying ability and longevity have been truly displayed. Bearings of this type are original equipment in practically all heavy-duty engines and are available for service at your request. As the CL77 is a precision bearing, it cannot be resized. The proper method to use for accuracy is to line bore the bearing saddles and caps. Here, approximately 10 thousandths is being ground off the face of the cap. The cap is precision finished and ready for installation. Do not under any circumstances attempt to do this operation with a file. The cap fits into position with perfect flatness. Studs are now put into position and run down with the spinner wrench. They should be tightened snugly with light pressure. Then use the tension or torque wrench to set them up with the prescribed tension. After the boring operation and when the bearings are inserted, the studs should be reinstalled with exactly the same pressures. The main bearing caps and saddles are now bored to fit the standard precision CL77 bearing. Very little material is removed from the saddle. Most of it is removed from the cap, which retains the original position of the bores within a few thousandths. This operation gives perfect alignment for the reground shaft. When precision bearings are fitted in this manner, the crankshaft turns with ease. This shaft was fitted with 2 1/2 thousandths clearance. Now, let us assemble the engine. Hey, don't put that head on yet. Many cylinder heads are warped and many need resurfacing. Check the head carefully, as failure to pay attention to this detail may cause premature engine failure. Normally, a light cut from the face will expose the high spots, which are generally found at the bolt holes. Note these high spots and the low ones at the combustion chambers. This causes gasket failures. The resurfaced head will now be placed into position. Here again, let us caution the mechanic regarding the importance of careful workmanship in the installation of cylinder heads. Cylinder head nuts and studs should be pulled down in their proper sequence. Do not do this job in a haphazard manner. Consult your Thompson repair and tune-up manual. To many mechanics, this wrench handle is too short, but that won't worry them as they have a special tool for this job. If you can do this with your bare hands, let's see what can happen when too much pressure is applied. It is normal to just run the nut to position and tighten it. Then one more turn to make it really tight. Here is where the trouble starts. Normally the studs are between or near the valve ports. Extra pressure applied in this area will cause distortion in the block deck, which in turn forces the valve seat out of square, interfering with its alignment. This disturbs all of the accuracies that have been built into the parts and the valve refacing job. The valve is forced off its seat and allows passage of burning gases, resulting in previously explained poor valve life. So, discard that pipe and do this job with the tension or torque wrench. Follow manufacturer's specifications as to proper pressure and sequence, and your repair job will give lasting satisfaction. Carelessness in regrinding crankshafts may cause out of balance, as shown here. This shaft is only a few ounces out of balance, yet it would cause considerable vibration in the engine. Metal is drilled out of the high side of the shaft, and it is again checked for balance. The shaft is now in perfect balance and will contribute greatly toward more satisfactory engine performance. Likewise, it is good practice to balance flywheels and clutches. They should be balanced separately. After assembly, again, balance the completed unit. This new flywheel and rebuilt clutch exchange required the drilling of several 9/16" holes to bring it into balance. Starting motor and generator armatures, as well as all rotating parts, should be checked for balance. Precision balancing is a necessity in modern engine repair. Dynamometer testing of rebuilt engines also is very desirable. In addition to more scientific carburation and ignition adjustments, initial break-in and run-in assures proper mating of all components. The run-in engine is now given a coat of paint and turned over to the owner, ready for many thousands of miles of trouble-free service. It will receive tender care by some and nothing but abuse from many others. And speaking of abuse, let us watch Joie Chitwood's gang of daredevils give both man and machine a terrific beating. These men trust their lives with Thompson tie rod ends. In the normal automobile, there are only two main actions which take place, and they are important. One, as the car goes over bumps and irregularities on the highways. The second takes place as the steering wheel is turned to change the course of travel. The Thompson dual-bearing tie rod end provides wearing surfaces for both of these motions. Before you is the body and the inner bearing, which provides the dual bearing principle. Finally, the stud that works in harmony with these parts. These three parts are the major components which, when assembled, are the safest and most durable tie rods money can buy. Let's watch these parts in action so the principle of the dual bearing can be more clearly understood. As the car travels over irregularities on the highway, motion takes place between the outer forging and the outer shell surface. This motion is entirely independent of steering. Now, the motion of changing the course of travel, or the steering action, is illustrated. This motion causes rubbing action between two entirely new surfaces. Likewise, it can be readily understood that since the motion is divided between two surfaces, wear will be divided equally. This mechanism represents the utmost in steering tie rod construction. It represents safety and endurance and is manufactured only by Thompson and is made available through your Thompson distributors. In the laboratory, where engineering minds create these fine achievements, test apparatus duplicates the stress and strains experienced on the highways. With equipment of this kind and the constant study of mechanical weaknesses, a new front suspension was born. It is known as the ball joint front end suspension. Here it is in motion. It is original equipment on one of our finest automobiles, and the next few years will bring it to common usage. Note the simplified construction of this suspension. The old king bolts and bushings have disappeared. The threaded joints have also disappeared. Two ball joints, one upper and one lower, do the entire job. Here, for comparison purposes, are the old and new suspensions. Again, note the simplicity and the reduction in number of wearable parts. Also, the weight difference of over 2 pounds per wheel. With the threaded joint construction, there is normally 15 to 20 thousandths of an inch clearance between the threads. This is to eliminate any chance of bind as the car goes through the many distortions caused by irregular highways. With tight-fitting threads and the presence of sludge occasioned by the varying weather conditions, it becomes impossible to provide lubrication, and a poor ride and hard steering result. Here is the proper joint with clearance as used by original equipment and supplied by your Thompson distributors. With ease, the grease flows to the threads, and there is no danger of binding from road deflections. This means ease of steering and safety. Thompson's national advertising program is designed to inform the car owner of the advancement made in the durability and safety of the American automobile. And the many years we have served the industry through manufacturer, jobber, dealer, and independent repairman. We also remind the owner of the constant improvement taking place in the industry and the importance of the repairman who takes care of his service needs. So that he can find these automotive technicians, we have designed this certified dealer window decal for identification, which ties in the repairman with this national advertising program. Consult with your Thompson distributor for further information regarding this valuable franchise. It ties the repairman to both the Thompson and Ethel valve rotation programs. Remember, your Thompson distributor offers one-stop service on all of these Thompson products, one or more of which are used as original equipment on every car, truck, bus, tractor, and aircraft built in this country. He likewise offers a complete Thompson chassis parts service, including spring bolts and bushings, Harris and silent U-shackles, and dual bearing tie rods, a complete line of front wheel suspension parts and water pumps, all of which are used as original equipment. And again, a final salute to America's automotive technicians.